Bismillahirrahmanirrahim. We are still in this topic, which is finding the limit at infinity. We have discussed in the first part how to find the limit at infinity, and we stated some theorems and we gave some examples. In this part, we are continuing to give more examples how to find the limits at infinity using different type of functions, either rational or radical, or maybe difference between two functions. And let's start with first example for this part. With the limit. Example number 1. Find the limit of this function, which is 2x squared minus 3 to power 2 multiplied by 3x plus 1 divided by 4x minus 2 squared multiplied by x minus 3 squared, or to power 3. While x goes to plus infinity. As we said in the first part, this is the rational function, and for the rational function we have polynomial divided by another polynomial. And to find the limit for the polynomial, we are taking the highest power for the polynomial. Now in this case, I have the polynomial are written in the factors form. So either we need to open the brackets and multiply it to write it in the standard form of the polynomial, or as we mentioned before, we can take the highest power from each bracket. Since I have two brackets or two factors, I'm going to take the highest power from each one of these. So we will take the highest power. So this is equal to limit. Highest power for the first bracket is 2x squared. And we have to keep the coefficient also, this 2x to power 2, and also keeping the power outside, the outer powers. So the first bracket will give me 2x to power 2 or to power 2 multiplied by the highest power from the second bracket will be 3x. For the denominator, I have 4x also to power 2, keep the power 2 or the outer powers, multiplied by x to power 3 as x goes to plus infinity. Now simplified, I will have limit of, this will be 4, x to power 4 multiplied by 3 multiplied by x to power 1 divided by 16 x to power 2 multiplied by x to power 3 as x goes to plus infinity, which is equal to limit 4 multiplied by 3 is 12 x to power 5 divided by 16 x to power 5 as x goes to plus infinity. And you can see that we can simplify, we can cancel x to power 5 with x to power 5, then I will have the limit is equal to 12 over 16, or to simplify it by dividing by 4, it will be 3 over 4. So the limit for this function is equal to 3 over 4. The limit for this function is equal to 3 over 4. Let me take another example now. Number 2. Let's find the limit of third root of 2x to the power 9 plus 4x to the power 5 minus 3x squared plus 2 divided by 8x to the power 9 minus 2x squared plus 4x plus 1 as x goes to plus infinity. I need to find the limit for this function. As we stated in the first part that this is a function to power 1/2. We can take the limit inside the power. So this can be written as third root of limit of 2x to the power 9 plus 4x to the power 5 minus 3x squared plus 2 divided by 8x to the power 9 minus 2x squared plus 4x plus 1 as x goes to plus infinity. Now what is inside? It's just a limit of the rational function. I have polynomial divided by another polynomial. So we can apply the theorem that the limit for the polynomial is equal to the limit of the highest power of that polynomial. So this is equal to limit highest power for the numerator is 2x to the power 9. Highest power for the denominator is 8x to the power 9 as x goes to plus infinity. We can simplify this one. X to the power 9 will cancel x to the power 9. So what is remaining now is equal to square root of 2 over 8 or square root of 1 over 4. If we simplify it, square root of 1 over 4 is equal to 1 over 2. So the limit in this case is equal to 1 over 2. So the idea is take the limit inside, then apply the theorem that the limit of the polynomial is equal to the limit of the highest power, keeping with the coefficient also. So it is 2x to the power 9 divided by 8x to the power 9, then simplify. X to the power 9 will cancel x to the power 9, I will have 2 over 8 or 1 over 4, and the square root it will be 1 over 2. One more example. Number 3. Let's find the limit of x squared plus 3 minus x as x goes to plus infinity. For this example, you can see that the first part, limit of square root of x squared plus 3 is infinity. And limit of x is again infinity. So it is infinity minus infinity. It is in this form. Infinity minus infinity, some people will say that this is equal to 0 because it is infinity minus infinity, but this is not true. Infinity minus infinity is one of the indeterminate cases. So we don't know what is infinity minus infinity. So if we have this type of functions or outcomes, we need to simplify it first, then we can decide about the limit, whether it is 0 or not equal to 0. So I have infinity minus infinity. I will call this is called indeterminate case. This is similar to the form 0 over 0. So we have to simplify it. We need to simplify. And since we have radicals here, so we are going to multiply by the conjugate. This is equal to the limit of x squared plus 3 minus x. Now we are going to multiply this by the conjugate, which is square root of x squared plus 3 plus x divided by x squared plus 3 plus x, up and down. Simplify it. Now I have a minus b multiplied by a plus b, which is equal to a squared minus b squared. It will be difference between two squares. So this is equal to limit. For the numerator, it will be the first one square minus the second one square. That is x squared plus 3 minus x squared divided by x squared plus 3 plus x, where x goes to plus infinity. As we know, square will cancel the square root. Then I will have limit of x squared plus 3 minus x squared divided by square root of x squared plus 3 plus x. And x squared will cancel x squared. I will have 3 for the numerator. So this is equal to limit of 3. Now for the denominator, we have to do something with the square root. I have x squared, or square root of x squared plus 3 plus x. Now I can take the limit inside the square root and then choose the highest power. So just for make it short, I will say that for the denominator for the square root, I will take the highest power only, plus x. Take the highest power for the radical. Take the highest power. Now, if we want to take it outside the square root, I will have 3 divided by square root of x squared equal to absolute value of x, plus I have another x there, as x goes to plus infinity. Now, to get rid of the absolute value, since x goes to plus infinity, so the absolute value of x will be equal to x, because x is positive in this case. This is the limit of 3 x plus x. This one, because we have plus infinity, this will give me x. As x goes to plus infinity, which is equal to the limit of 3 divided by 2x, as x goes to plus infinity. And from the theorem, since we have x down with x goes to infinity, this is equal to 0. So I got 0 at the end. So the limit for this function is equal to 0. We go back to the problem. So at infinity minus infinity, and at the end I got equal to 0. Does it mean this is equal to 0? No, it is not. Infinity minus infinity is not equal to 0. It is something that we don't know. We call it indeterminate case or form. So infinity minus, if you got infinity minus infinity, it doesn't mean that you will have 0 at the end. You might have 0, but in some cases you don't have 0. And let me repeat the same example with just a little change in the problem. This will be number 4. Suppose that you are given this problem, limit of x squared plus 3 minus x. This was the problem in example number 3. Now if we add this part, make it not 3, I will make it 3x. So the problem is now changed to be square root of x squared plus 3x and the other square root minus x. Again, this is infinity as x goes to infinity. Sorry, this is as x goes to infinity plus infinity. You will have infinity minus infinity. We need to check this one. Are we going to have 0 in this case or not? As we did exactly the same steps, just we adding that x, the chain that we did for the problem. So multiply by the conjugate. Will be square root of x squared plus 3x minus x multiplied by the conjugate. Conjugate in this case will be x squared plus 3x plus x divided by x squared plus 3x plus x. Multiply and simplify. I will have limit of the first one square minus x square, the second term square. So it is square root of x square plus 3x all square divided by square root of x square plus 3x plus x as x goes to plus infinity. Square root will be cancelled with the square. So I will have now the limit x square plus 3x minus x square divided by, to make it short, I will take the highest power from the square root. Take the highest power down. Plus x. So I remove this one because this will be 0. So I took the highest power from the what is inside the square root, which is x squared. Now x squared will cancel x squared. So in the numerator, I will have 3x. For the denominator, since I have square root, I will take the x outside the square root and it will be absolute value of x. This is by the definition. As x goes to plus infinity. And since x goes to plus infinity, we can take x from the absolute value of x as x without any change. From the definition of the absolute value, it can be x or minus x, depending on the value of x. If x is positive, it will be x. If x is less than 0, it will be minus x. And in our case, x goes to plus infinity, so it is positive. So this is equal to limit of 3x over x plus x as x goes to plus infinity, which is equal to limit of 3x divided by 2x as x goes to plus infinity. And it is very clear that we can simplify this one. X will cancel x, then I will have 3 over 2. So the limit in this case is 3 over 2. If we go back to our example, so infinity minus infinity in this case is not equal to 0. So you have to be careful about this one. If you have infinity minus infinity, in some cases, it is equal to 0. I mean the limit equal to 0. Some other cases, this is not equal to 0. And this is very clear in example number 4. So infinity minus infinity is not equal to 0. Or what we did, multiply by the conjugate, simplified, take the highest power from the radical, and simplify it more to get 3/2.